Q and R. I'm waiting for you to give me the answer. So try C and D for me. Okay, what did we get for C? What did you get for C? Yeah, I heard.
Yes, I'm still working with the negation sign.
Okay.
I got true.
True. Okay. Good. Let's check. So this is true. Okay. Or this is false. And not R is also false. Okay. Good. So we start with the brackets. That's false, and false will be false. Okay. And then true, we remove the brackets. That will be true, or false will be true. So you're correct. Then when we come here, this will be false or false. This will also be true or true. Then we have the last statement to be true or false. Good. So when we take them per bracket, this should give us false. The first statement will be false. The second statement will be true.
True.
And the last statement will also be true. Okay. We have a disjunction here, and we have a conjunction here. Okay. And per our board mass, we know we always give priority to what? To conjunction, that is and. And is like multiplication. Okay. So we work F and true first, which will be false, or truth, which will result in a truth statement.
Okay.
Okay. Very well. So with that understanding, yeah, we asked to write, it says let P and Q be the proposition. Temperature is more than 40 degrees and raining. Write the following prepositions using P and Q and logical connectives. Okay. The temperature is more than 40 degrees, but it is raining. How will you put that statement? Yes, class, I'm listening to you. Jacob? Jacob.
Yes, sir.
Yes, 3A. Can you write the preposition for us?
I'm coming in a moment.
Okay. I guess a number of you are having challenges with your network. So let me take that. You see, ideally we expect that once the temperature is low, okay, then we expect a rainy day, okay? But this is the case where we have temperature more than 40 degrees and it is raining. The reason why we are not writing and is because we expected that it would be a sunny day, but it is not so. So we are saying that the temperature is more than 40 degrees, but okay, it is raining, meaning we didn't expect it to rain, okay? But the word part there represents the word and. Okay, so if we are writing this, this would have been what? P and what? P and Q, okay? It cannot be or. Okay. Now you try the B and the C too on your own at home. I'll post it as an assignment for you. Okay. Let's continue. Now, we also have what we call as the conditional probability, conditional preposition. Okay. For conditional preposition, we usually read it as if P then Q, okay? If P then Q. And the connective is that the arrow here, that is if P, okay, then Q will result. So for example, if we are given the statement, faculty is allocated another scholarship, okay? Faculty is, faculty is allocated another scholarship. Then Q, Ravi can further his studies at University of Sheffield. Okay, what it means here is if we connect this by conditional preposition, then we are saying if faculty is allocated another scholarship, Ravi can then further his studies at University of Sheffield. Okay, that is what we are saying. Now let's take the truth table for the conditional preposition as well. Okay, take note of it. Here, the only situation where we'll get a false statement is when we move from a truth statement to a false statement. In other words, your premise is true, but okay, your Q is a false statement. Okay, good. Then the resulting compound statement will be a false statement. Okay, good. I'm sure you've taken note of the table before I continue. Good. Now, we have some examples here. He says P is the statement 1 is greater than 2. And Q is the statement 4 is less than 8. We know that P is false and Q is what? True. Okay, because 1 is not greater than 2. Okay, but 4 is less than 8. Therefore, the proposition P implies Q. That is, if 1 is greater than 2, then 4 is less than 8 is true. Okay, we said the only condition under which we'll get a false statement if we move from what? True premise to a false what? Statement, okay? From truth to what? To false, okay? So you take note of that. I told you to take note of the table up here. This is it, okay? So the only condition under which you get that is when you move from true to false. Else, every other thing is what? Is true. Okay, let's move on to by conditional preposition. By conditional preposition, okay, which has a two-way arrow like we see here, okay, is read as if and only if, okay. In other words, P implies Q and Q also what? Implies P. Good. So we read it as P if and only if Q. Good. And the truth table is as follows. The only condition under which you get a truth is when both statements are true or both statements are what? Are false. So when both statements are true or both statements are false, then we get a truth value for the biconditional preposition. Okay. So you take note of the table as well whilst we continue. Okay. Very well. So there is a statement here. It says we define P as 1 is less than 5, and then Q as 2 is less than 8. Okay. So if we write, then the statement 1 is less than 5 if and only 2 is less than 8. Okay, it's going to be true because this statement is true, and then this statement is also true. And we said any time we have the two statements being true, then the biconditional, okay, connectivity will result in a true what? Statement. Very well. Okay, so we have some examples here we have to try. So in this activity, it says write each of the following statements in the form if P, then Q in English. Okay. Okay, can you give it a try? Try question A and B for me. It says you should write the following statement in the form if P, then Q. So do that on your own for me. Okay. Yeah, are you done? Are you done, class?
Yes,
Can I have your answers?
it's true.
Yes, we're supposed to write it in a statement form. If not the true statement. The instruction says, write the following statement in the form this. So how would you have written it? In other words, rephrase the statement, okay, to sound if something, then something. So it rains whenever the wind blows from the north. Okay. So let me give you a clue. If we take this to be statement P, the wind blows from the northeast. And then,
Hello?
yeah, I'm listening to you.
Can I give it a try?
Yes, go ahead.
If the Pistons win the championship,
Please
wow,
come again.
okay. Please go on. It's not that clear. I thought I had it, but it's not that clear.
Okay. So let's look at the first one. The first one, if we take this second statement here as P, that is wind blows from the northeast. And then we take this statement as Q. Okay. Then we can write the statement as what? If what? If P, okay, then we have what? Q. Okay. In other words, if the wind blows from the northeast, then it will rain. Okay. If the wind blows from northeast, then it will rain. Okay. This is another way of rewriting the given statement. Okay. The same way, if we look at B, which says the Pistons win the championship, implies that they beat Lakers. Okay, implies that they beat Lakers. Okay, so I think it's straightforward. We can rewrite this statement like if the Pistons won the championship, then they beat the Lakers, because this word here already means implies is what? If. Okay. If the Pistons won the championship, then they beat the what? The Lakers. So it means that we'll take this as statement P, and then this as what? Statement Q, and write it as what? If P, okay, then Q. Okay, if we're writing this notation, if it's already there, this is already if then. So P implies what? Implies Q. Okay, so try the other examples on your own as well at home.
Can I try the C now?
Yeah, go ahead.
So if it is necessary to walk a few kilometers, then get to the top of the mountain.
No, it doesn't sound okay. So first you need to pick your Q. Which statement will come first?
The Q, which is if it is necessary to walk a few kilometers.
No, you see, it's an action you are taking. The final results will be at the top of the mountain. Is that not so?
Yes.
Sir,
Yeah.
sir,
So, yes.
can I please also try?
Yes, go ahead.
If getting to the top of the mountain, then it is necessary to walk a few kilometers.
Yes, you're almost there.
If necessary, okay, if getting to the top of the mountain,
If you
okay,
have
getting to the
to,
top of the,
if you have to get to the top
okay,
of the mountain, yes.
Okay.
Are you getting it?
then it is necessary to walk a few kilometers.
Yes, that is it.
Okay.
Uh-huh.
So it can also be to get to the top of the mountain, then it is necessary to walk a few kilometers.
You see, now it doesn't sound too nice because you've left the if out.
If. Yeah.
Sir,
Yes.
plus, is it always that you have to use the letter if, the word if,
Yes.
or you can replace it with any other?
No, you see, you have to use the word if then. Okay.
If.
Now,
Okay.
the trick
Okay.
with these logical connectivities is in programming. Okay, these are standard symbols which are used in programming. You understand? And you should be able to convert a statement. So, for example, if I say that not all that, all that glitters is not gold. How do you program that? You get it. You first have to dissect the statement into its various components. The first component is items which glitter, and then items that are gold. Are you getting it? Then you can write the program, okay, using the logical, that statement is a predicate logic.
Yes.
So you can use the predicate logic notations, which are standard programming notations, to program your computer. So the computer or the robot will be able to, reason with those logical mathematical expressions. You get it? So he picks it as, if I have to get to the top of the mountain, then I have to walk 3 kilometers. That is how the computer will interpret it. But if you change it and then you make any statement, it becomes difficult to program it. So that is the essence of this whole thing. Okay.
Thank you.
Now let's go to the next logical connectivity. Okay, here we're looking at tautologies, contradictions, and logical equivalence. A tautology, like it sounds, okay, is a statement which will always result in a truth outcome. And a contradiction will always result in a false outcome. So as an example, we have P or not P will always be a tautology. P and not P. So for example, you have P, then you have not P. So we have P, we have truth, we have false, not P is false, and then we have this to be true. So if we combine this, P or not P, obviously both statements will end up being what? True. So anytime you have a statement where the truth outcomes are always going to be true, then we call such a statement a combined statement what? A tautology. Okay. And the same way, if you have P and not P, P and not P, okay, we'll rather end up having this and this will be false, and false and true will also be false, okay? So P and not P will always be a what? A contradiction. Okay, that's what we are saying. So contradiction always results in false statement, whilst tautologies always result in truth statements. Okay. Now let's move on to logical equivalence. Now, when we talk about logical equivalence, we are saying that if we have two or more statements, okay, different statements, okay, which if they are logically equivalent, then their truth outcomes should be the same. So, and to write, or the notation for logical equivalence is what you have here. It's like an equal to, by this time we have three, okay, parallel lines to each other. So we say that the two statements P is logically equivalent to the statement, a compound statement Q. Okay, so let's take an example to demonstrate that. So we are asked to show that the statement not the negation of P implies Q is logically equivalent to P and not Q. Okay, good. And to do that, you first have to create a table like you have here. Okay, so we have the first table. There are two statements involved. So we know we're going to have 2 raised to the power 2, which is combination of 4, right? Good. And 4 means you're going to do with 2 truths and then 2 false first. So 2 true, 4 false. Then we have true, false, true, false. Okay. Then afterward, you may choose to finish what is on the left side first. Okay. So in doing so, you create these headers. So if we're looking at what is on the left side first, then this will be your first column, which is P implies Q. P implies Q, okay, like we said, the only condition under which we get a false statement is when we move from truth to false, okay? So true to false will give us false here. Otherwise, we have truth, 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 okay? Then the negation of that statement will give us false, true, false, false. Okay, that will be for the left hand, this left hand side, okay? This is the left hand side. And on the right hand, you need to first find negation of Q, which has been done here. Okay, so you have F, T, F, T. Then you combine using the connective, that's conjunction. So P and not Q. So you have to create that column here. P and not Q will give us what? True and false will be false. True and true will be true. False and false will be false. And then false and true will be false, okay? Now, the reason why we say that these two are logically equivalent, okay, it's false and false. When this statement is true, this is also true. When this statement is false, this is also false. And then when this statement is false, this is also false. So it means that they have the same set of what? Truth values. When that happens, we say that the two statements are what? Are logically equivalent. Okay, that is what we mean by logical equivalence. Okay. Now, any question? Okay. Okay, so since there is no question, I'll move to the next slide. We hope to cover the next topic too before we leave. Yeah, so these are properties which we need to know, okay? Properties which govern prepositions. The commutative property holds for conjunction and disjunction. Associative property also holds for conjunction, for both conjunction and disjunction like you're seeing here, okay? Distributive, idempotent property, negation, And of course, the De Morgan's laws, okay? De Morgan's laws are very, very important for those of you who have done digital electronics, okay? You came across the topic expressing in the minimax and the maximax, okay? Well, we need the De Morgan's law to break Boolean expression into simplest form to enable us to implement, okay, the minimax, okay, circuit for which operates in the same way as a bigger circuit, okay? And this accounts for the differences in the speed of a lot of these computer devices, okay? How the architecture is designed is based on how the De Morgan's rules have been broken, or how the Boolean functions have been broken down based on De Morgan's rule, or based on Carnap maps and etc. So you need to know these rules very much. It should be off head, okay, because you need it in various fields, in this topic as well as in your various computer science fields as well. Okay. Now there are some questions also for you to try on this topic. That is exercise 5.3. Try and give your hands, try and attempt those exercises. Okay. So, for example, in a case like this, I think there are some few mistakes here. I'll correct them and post them for you as an assignment. Okay. Because here we have just 2 statements, but here you have 3 statements. Okay. Very well. Now, the final thing we would also want to look at on propositional logic is the difference between contrapositive and converse. Okay, good. Definition 5.5 tells us what a contrapositive is. It says that a contrapositive for the conditional proposition P implies Q is what? The preposition not P implies not Q. Okay. So that is for the contrapositive. Good. And then key here is we need to distinguish between what? Contrapositive and converse. Okay. Like we're saying, the converse of a conditional proposition merely reverses the roles of P and Q. So P implies Q will just be what? Q implies what? P. This is not the same as what? It's not the same as the contrapositive, which is what? Not P implies not Q implies not Q. Okay, so this is the converse. This is the converse, whereas this statement is the contrapositive. Okay, I think the next example also touch on the differences very well. So when we come here, so he says if we define P as 3 is less than 4, whilst Q is 5 is greater than 8, okay? We know this statement here is true, but this statement here is what? Is false. He says then the given preposition, if P, then Q, okay, is written symbolically as this, right? Good. But we know that because this is true and this is false, the result will be what? Will be a false statement, because we are moving from a truth premise, okay, to a false statement. So that will be false. The converse of the statement will be what? Q implies Q. Or in words, if 5 is greater than 8, okay, then 3 is less than 4. This statement is going to be what? It's going to be true. Okay, this is true. So we can see that this statement here, P implies Q, okay, is never equivalent to what? It's never equivalent to the converse, which is what? Q implies what? Q implies P. Okay, good. Then when we come to the contrapositive, that is not P implies not Q. Not P, not Q is not Q will be true. Okay. Sorry, not Q. Q is false. So not Q will be true, right? Good. And then we have implies what? Not P is false, okay? Not P is false. So clearly we can see that true to false will also be what? False. So in simple words, we can say that then the contrapositive, okay, is logically equivalent to what? The statement P implies what? Q, okay? Good. So in summary, we are saying the contrapositive is equivalent to the conditional preposition, but the converse of the preposition, the conditional preposition is not equivalent to the initial statement itself. Okay. Yeah. Then let me check the very final slide before we move on.